You ever click a link and just stop and think about it? I mean, how does that one little click right there in your house almost instantly bring up a website from a server that could be thousands of miles away? Well, today we're going to pull back the curtain on that magic. We're going to follow the amazing journey of a single piece of data from your screen all the way across the globe and back again.
So how do we even start to unpack all of this? We're going to do it by following one tiny piece of data, what's called a packet, on its incredible journey. Just think of this packet as your own little digital messenger, carrying your request out into the vast, wild world of the internet.
All right, so every journey has a starting point. And for our packet, that journey begins right where you are, on your local network, or, what the tech folks call a LAN. This is basically your digital neighborhood. It's all the devices in your home or your office that are connected and talking to each other.
Now, inside this digital neighborhood, there are two devices that are the real stars of the show. You've got a switch, which you can think of like an internal mail sorter for a big office building, directing traffic inside. And then you have the router, which is kind of like the main post office that connects your entire building to the rest of the city.
And here's the deal with how they split up the work. A switch, it's all about local traffic. It uses a very specific kind of address to get our packet between devices that are on the same network, like from your computer over to your printer. The router, though, that's the gateway. Its whole job is to take that packet and send it packing out into the wider world.
So that local address the switch is using, that's called a MAC address. The absolute easiest way to think about this is like a fingerprint for your device. It's unique, it's permanent, it's literally baked into the hardware, and it never ever changes. It's how devices in your little digital neighborhood recognize each other.
Okay, so our packet is zipping around locally, but how does it actually leave the neighborhood? Will it get onto that global highway, the Wide Area Network, or WAN, which is really just what we call the internet? Our packet needs to graduate from the local streets and get a whole new kind of address.
And that new address is the famous IP address. If the MAC address is your device's permanent name, the IP address is more like its current mailing address. It's what lets any other computer, anywhere on the planet, find it and send information back to it.
But, and this is where it gets really clever, not all IP addresses are created equal. You've actually got two kinds. There are private IP addresses, which are only used inside your local network. And then there's one single solitary public IP address that represents your entire network to the whole wide world.
I think the best analogy for this is an apartment building. A private IP is like your specific apartment number, say apartment 4B. It's super important for getting mail delivered inside the building, but totally useless to the postal worker on the street. Your public IP, that's the building's main street address. It's the only address the global postal service, the internet, cares about.
So how does this all work? It's managed by a process called Network Address Translation, or NAT. Your router basically acts like a brilliant receptionist. It takes all the outgoing mail from every apartment, every device with its private IP, stamps it with the building's main address, and sends it out. And when mail comes back, it knows exactly which apartment to deliver it to.
Okay, our packet is officially on the internet highway, but it's not the Wild West out there. It can't just drive wherever it wants. It has to follow very specific rules of the road, or what we call protocols, to find its destination and make sure its message actually gets understood when it arrives.
The very first rule is figuring out where to go, and for that, we use DNS, the domain name system. Just think of it as the internet's giant phone book. You and I, we remember names, like Google.com. Computers, not so much. They need numbers. DNS is the translator that turns that name into the actual numerical IP address our packet needs to find the server.
All right, address in hand. Now our packet needs a delivery service. And on the internet, you basically have two main options. You can go for a super reliable, careful delivery service called TCP, or you can pick a lightning-fast, no-frills option called UDP.
Let's break this down because it's really cool. TCP is like sending certified mail. It makes a phone call first to make sure someone is there, it numbers all the packages, and it gets a signature to make sure every single one arrives safe and sound. Perfect for loading a web page where you need everything to be perfect. UDP, on the other hand, is like sending a postcard. You just write it and drop it in the mail. It's way faster, but there's no guarantee. This is great for stuff like video streaming or online gaming, where getting the data there fast is more important than getting every single bit perfectly. Now,
Let's zoom out for a second. Our one little packet is just one of billions flying around the internet every single second. So how on earth do network operators keep all of that running smoothly, securely, and quickly, especially in a giant company with thousands of devices? Well, the answer is the network itself is getting a whole lot smarter.
And this is where network automation completely changes the game. It's all about using really powerful software to manage, configure, and even troubleshoot the entire network from a single place. We're talking about turning what used to be weeks of manual work by engineers into just a few clicks.
And the payoff here, it's huge. You can roll out new network services way faster, you get way fewer mistakes, and let's be real, a simple typo by a human can cause massive outages. And you make sure your security rules are the same everywhere. It just makes the whole system run better. So far, we've kind of been picturing our packet zipping through physical cables. But let's be honest, most of the time you and I are on Wi-Fi, right? So what happens when our packet's journey starts by flying through the air?
Well, the very first handshake on a wireless journey is with a device called a wireless access point, or just an AP. Its job sounds simple, but it's absolutely essential. It's the bridge. It translates the radio waves coming from your phone or laptop into electrical signals that can travel on the wired network where the rest of the journey continues.
And you definitely know this access point by another name. It's SSID. That's just the fancy technical term for the Wi-Fi network name you pick from the list on your phone. It's the AP's way of shouting, "Hey, I'm over here and I can get you connected."
And of course, with all our data flying through the open air, security is absolutely everything. It's been a real cat and mouse game over the years. We've gone from the old, easily breakable web protocol all the way to today's gold standard, WPA3, which uses incredibly strong encryption to keep our information safe from prying eyes.
So there you have it. In literally the blink of an eye, our tiny little data packet has performed this incredible high-speed ballet. It navigated your local network, grabbed a new passport for global travel, followed all the rules of the road, and reached its destination. All just to bring you the content you asked for with a single click. And you have to remember, this whole process isn't just happening once. It's happening millions of times a day for every single one of us. It's the invisible engine that powers our modern world. And it really leaves you with a fascinating question to chew on. As more and more of our world comes online, I'm talking about our cars, our refrigerators, our coffee makers, how is this incredible network going to evolve to handle all of it?